Alright. Hey guys, we're back. We're apparently live. Okay. Let's see if that's the size of our window. Alright, so where we left off, we had a bit of a problem. We were kind of stuck with our iterations, I guess you could say. Our steps were like skipping steps. Now that I think about that, that makes me think we're appending and popping off wrong. I'm gonna get rid of that copy because I don't think we need that. And then I want to change the order that we iterate through these. I want to say that we iterate through top, right, bottom, and left. Clockwise just seems make more sense. I know there's way more sophisticated ways to do this, to avoid converting back and forth between index and position. Finds the next step. Next vertical, horizontal step for each of the current mapping squares. Finds the next valid. I almost want to put this stuff in the square and iterate through each square, because that would make a little more sense to implicitly say like in square available map, and then available path, something like that. And then we don't have to do all of this like internal logic in the pathing. We would still have to index into them though. Let's just run this and see what happens. So in this case, we hit our own square again. So let's go through this logic. if we have not mapped, I'm gonna move this out of this find path loop and just never call this function if these things are not valid. And we could create a function out of this and pass it to the top. And we could probably split this up into two functions. But anyway, we determine if we're mapping the distances. So we're not mapped. The length of mapping squares equals 0. We append the exit index. So now we have one index. See, and this is where I think we could say, we could actually put the square here. But we really don't need to. If we have the index, we can just index into that square, so it doesn't really make a difference. But we can, instead of doing these logical checks here, we can definitively say that we still would have to check the adjacent square. So what we would do is we would say, if the x and y is in the bounds, then return self dot squares not mapped ready to map. And then we don't have to worry about these functions. What do you get me for adjacent squares? What is this? You know, that might be a better way to do this, actually. We could say, if we check the map squares, we append position. And I think this is how I did it in my old code. And we can say, let's move this up. Let's just say self dot mapping squares. We'll reinitialize it as a blank list. That's simple enough. Clean up mapping squares. So find the next squares. We can actually say for square, in current square iteration, if the square is the in index, or ooh, we could just check it here actually. No, because this one has already been mapped. This one is already on the map. We've already done the preemptive check. But we can say if the square is the starting index or square is the end index, then we will just continue. We're also going to want to add a check here to do check if we are at the start, if we have found the start. And we could do that here, I guess. We'll come back to this logic. We'll come back to it. Let's see what happens now. So we're still canceling out our start index. Are we doing something wrong when we create the end location? That'll work. Let's do that. So what are we doing that hits this? Because we're not hitting this point. We're just setting the color to gray. So the problem wasn't there, it's here. So this is where we say if the square index is in self dot in index self. Actually, we'll say if square index equals in index, we will say that we are done. Actually, no. If we are at the start index, we will say we're done. If square index equals the end index, then we are not walking yet. I think that'll work. Let's see. Square has no attribute ready to map. But it does here. How is that possible? Am I blind? It clearly does have that attribute. Ready to map. Excuse me, I've been sick. I've been fighting sickness. I'm sure this coffee helps. Shout out to this band that I just heard of. They're called Their Dogs Were Astronauts. Their Dogs Were Astronauts. Pretty cool. Shout out to those guys. I don't understand how it doesn't have this attribute. Ready to map. I don't know how else to call this function. Square has a set color function. Is not the same thing as this. How is that even possible? Whoa. Well, we have the whole grid now, but we are not walking. Why did we skip all of the walking? We also did not map our start and end locations, so that is good. Or rather, start and end. Oh, I forgot, you guys can't see this. So, it's not walking now. It's just completely done. In our main function, our UI, this should what if we move the clock up? This shouldn't make a difference. But if we say game if we put the tick in the running loop, it shouldn't make a difference. Yeah, it's still doing the same thing. So we can put this at the top level too. I wonder if we slow it down to like 1. I mean, it's really slow, but yeah, it's still doing the whole thing at once. Are we hitting our cleanup function? Maybe we don't return, we continue. Actually, for this one we can return, but we need to say, we need to do this little early exit. Great, now we have walking. And it's going extremely slow because we are doing 1 tick a second. There's a little bit of fragmentation at certain points, but I think that's okay. Because this is like deviation due to a wrap of the step, I believe. Maybe not. Yeah, you can tell. And so this works perfectly because these points here will have a farther distance than these points here, even though they have a closer distance directly. So now we can colorize this. We can also increase our speed again. So let's go back to like 15. And then now you can see we are walking the map in a decent amount of time. Perfect. Now, before we get into colorizing, let's go back to the pathfinding. And our cleanup function is wrong. Once we find a start index, we're not done. So this is actually completely wrong. But let's test and say print. Are we at the end? Let's test this because once we get to an iteration where we've cleaned up the squares and then we again are done with the squares, I'm hoping that our print statement continually hits. We should see that once this reaches the end of the map, we start printing that we're done. And that did not happen. I was thinking that once we hit here, oh, because we're appending the index here, so we're actually we're just stuck in a loop now. So we do actually need the mapping. So we need to say and self.mapping we can put that here, that's fine. Because if we're mapped, we just want to skip this logic altogether. We don't care if we're mapping or not. But specifically, because we will skip this one if we are completely mapped. We will skip this one if we are still mapping. So if we are mapping and we have a length of 0, then we will not hit this one. And we will hit this one, I think. Let's see if that works. So here's this iteration. It's cool seeing this work. And then we should start seeing print statement here once we get to the end. Yeah, we're at the end. Cool. So we can then say we reached the end. And then we can say self.mapping mapped equals false. Self.mapping equals true. And we could probably say walking. We could reuse the walking variable. And let's do that. Let's do that so we don't, because the walking is specifically gonna be used for pathfinding, but this also keeps us from trying to find a path while we are right, so if we're not mapped, if we are mapped and we're not walking, we'll never get here to the find exit. But so we can actually leave this a true. And then that means we'll have to do a check here. Yeah, I'm gonna actually, let's not use the walking. I can see problems with that, because it's representing two different states. And it's Python. I mean, it doesn't have to be perfect. So let's see if we hit our find exit function. And then we're gonna self.walking equals false. So walking needs to be set to true. So that's why these are different. Once we finish mapping and we have mapped, we need to set walking to true, because we have finished mapping and now we need to start walking. Just for sake of time, I'm gonna go ahead and speed this up. So we reached the end. I thought I changed that. Oh, we did reach the end. Then that means these checks are not working. So if we mapped and we are not walking, mapped is true. I had those backwards. We reached the end, we're finding the exit, we found the exit, boom. Okay, so now we have state. We are able to monitor the state. So after we clean up the mapping squares, let's call this reset mapping squares. Because once we reach the end, actually, can we pull this out? Can we move this up a level? Can we move it up here? So we'll only hit this one if we are not mapping. If we are mapping. And then we can go ahead and skip the mapping the endpoint distance. And then here's this. And then we still hit our loop. Okay, cool. So now our this is where we need to check determine if we are in a dead end and cannot move forward. And then the thing we need to do here, clean up dead squares. So let's create a little define clean up dead squares. I don't think that's right. Is it? If the square is not mapped and square it's ready to map. So all we have to do is say if the square is ready to map. If the square is in start and end index, continue. Otherwise, we want to, how do we do, what's our default? Oh, it is in path. No, it is in map. When we have to do a little bit of logic. Well, for simplicity's sake, we can just say that we're gonna make all of these mountains. We're not going to do it like that. We're going to set the color to brown, square outline equals 0, square dot path equals false, square dot map doesn't matter. I think that should be sufficient. We can improve this a little bit, but this oops, we still need to call this self.cleanup dead squares. So once this maps, it should find. Did it wrong. If it's ready to map, self.map. So are we not setting these to map after? That's probably what it is. We are setting it to mapped. We shouldn't need that because we should never get here, but that's just a more correct way to do this. Clean up dead squares if the square is ready to map. I had my logic backwards. So everything should be mapped by the time we get here. If the square is ready to map, that means we didn't reach it with our direct walking. So if we do this again, all of those, there we go. All of those other squares should just disappear. Very, very good. So, one thing that we need to check is I need to look at my other code. Because if our start location is in an unreachable area, then that means that we need to modify if our start location is in an unreachable area, then we need to find a new start location. So what we're gonna do is we're gonna just say okay, we'll come back to this because we're gonna use the pathfinding determine if the start location is able to find the end location. This is going to actually be pretty easy. Um, we'll come back to this. This one won't be too bad. So, determine if we are at a dead end and cannot move forward. Let's think, how can we do this? Let's pull out our trusty paint pad. I hate doing these grids like this, but it's one way to do it. That was great. Alright, so if what we're doing is we are starting in a box and then we are looking at the surrounding boxes, and then for each of these boxes we are looking at their surrounding boxes. And we're checking that the next box is in the map. It is not not walked. It's not mapped, as in distance. And that that it is in the map, that it is not mapped, and that it is a path. So, what we're doing we're going to just go through a couple iterations of this. Once we hit, so our green is the next one we're looking at. These are the ones we're going to append. The orange is the one that we're currently at. Once we move the orange up one, we clear out this list. We move the orange ones up. And then we look at the next ones. And we repeat the process. Now, how do we determine if we've made it outside of our own little square? We could potentially determine a threshold. That is one way to do it. And actually, with our current map, I mean, we could say we could measure the distance from this corner to this corner, and then if the distance does not reach that point, then we can determine that we have not mapped our square. That's odd, I didn't get that one. So let's do that. Let's say determine threshold distance. And then what we're going to do is we're going to say, where's our quadrants? I believe that's all it is. Get start quadrant. Get starting quadrant. And then we are going to say find edge position self, and then if self equals quadrant top left, we're gonna have to say map squares x, map squares y. So if we're at the top left, we're gonna just return 0, 0. If self equals top right, we're gonna do 1 and 0. Bottom left would be the height, and that's right. Okay, so now we can say target position equals the self. That's not what we're doing. We're not getting the starting position. We're going to get get edge position. And then what we'll do is we will define a Euclidean distance, and this is the straight line distance between 2 points, not the number of steps between 2 points. So self A and B, and this is the absolute value of, there we go. A minus B, x minus x plus y minus y. Do I need to import math or anything? No? Okay. And then so what we will do is we will set the self dot threshold distance equals 0. And we will also have to set a current distance. We have a current distance value. Are we using it? This way our current distance is always bound to a square. So our target position is, this is our target position. And then we can say self.threshold distance equals the self.Euclidean distance to the, from the end location to the target position. So our straight line distance from here to here should always be less than the actual direct steps path. So once our path gets to that point, we should be well beyond that point. And since we're going from this corner to this corner, this might be a path of 13, but the actual steps might be 18. So as long as we're our current distance, or I should say our current maximum distance, is greater than our threshold, we know that we've escaped a single specific area. So we should be able to say if the length is 0, actually as soon as we start mapping, we can say self.determine threshold distance, and then self.check completion status, check map validity, integrity, that's a good word, integrity. Almost messed up there. You gotta be careful with autocomplete and letting Copilot write your code for you, or ChatGPT write your code for you, because this stuff isn't conscious. You gotta remember that these machines are not conscious. They don't know anything. They don't even know what they're saying or typing or anything. All it is a binary event horizon. These are just weight maps. They don't know what words are. Even if they can tell you what they think words are, there's no validity in what they are saying. It's literally just a pre-programmed expression, a very complex one that seems to emulate human behavior, but that does not mean that it is conscious or aware. That's another talk for another day. So what we want to do is we want to check the map integrity if we have no squares left. And so we're gonna just check map integrity. If the mapping squares would be 0, if the self.current distance is greater than the self.threshold distance, and we can actually just return this. And then if we can check this, then we will exit all of this. If the map is not integral, anyway, we want to collapse endpoint. So what we're gonna do for this is define collapse endpoint. We know that this area is unreachable or cannot reach beyond where it's currently at. So we're gonna just say that while we'll say collapsing equals 0, while the length of collapsing self.end index is greater than 0. For this is not what I want at all, but if self.squares square index is ready to map, is that what it's called? Mappable. That's not what I want to do yet either. We're basically going to reproduce the other logic, but we want to do this in a single function in a lot faster way. So we're going to take the single index, and then for the square in collapsing, are we going to collapse it? I think we're going to do that regardless. We're going to do this at the end. We're going to say, or we can just do it at the start actually. And then we're going to say self.squares dot yep, we're going to check all the surrounding squares. Nope, we're not going to do that. We're just going to are we going to check the map squares? Is that how we're doing it? Okay. We're going to just collapsing dot append and I don't want to just do this for I don't want to just do this. I'm actually gonna get rid of this. We're gonna do x minus 1 I know this is probably gonna drive some of y'all crazy. X minus 1, y minus 1. We're gonna do all of these surrounding squares because we already know this area needs to be collapsed. We're gonna grow it as fast as we can. I bet it can do the rest for me. What's your problem? It's in parentheses. That's all of them. So we're just gonna add all the surrounding squares that are valid, and then we'll just continue to do this loop while the length of this is 0. Extend. We're not gonna extend it. And honestly, I have no clue if this is gonna work. We won't know unless it and then after we collapse the endpoint, we need to self dot find a new exit. Create end location is what we need to do. We won't know if we hit this unless we are in a dead end. But everything else works, so let's just assume that that worked. Oh, we hit a dead end and it's starting to spawn locations. That's not good. We didn't pass our distance. That's interesting. That's super interesting. What a weird bug. I wonder how. I mean, eventually the whole map should turn brown. So what we need to do is we need to print when we hit that check, what are we getting? Distance of 275 with the threshold of 269. So I could see in a location like this where we're not getting past that point because we can't get past this point. It'd probably even be safe to say that, so like this one we will have a way higher max distance. I wonder if we could even just say that half of that we could offset the distance of the current corner. Target position, offset position would equal the edge position of the current end quadrant. And then the offset distance would be the end location, and then the offset distance would give us the threshold. So we're just subtracting the distance from that quadrant point to the corner, and then that should give us a little bit more of a deviation. Yeah, so the threshold's 166, the total distance is 238. So we're counting the distance from this point to this point, and then we're also subtracting the distance of here. So as long as we make it past like this corner, basically, we know that we've basically traveled the whole map. And it's not exact. There's probably a lot better ways to do this, but this works well enough that we don't get trapped in one of these corners. I don't like doing this because I know that this is where our bug was at. What if we get rid of this and we steal the logic from up here? And we say self.mapping squares equals the end index and then we say the current iteration equals the mapping squares, and then while the length of current iteration is greater than 0, we are going to say for the squares in current iteration, we don't care about the distance. The next squares is, we're going to just find the next squares. We can determine that if the length of the next squares is 0, oh, we just continue because this is the next squares for a given square. That doesn't mean that all of them are done. There's a bit redundancy here, but we're gonna have to do this every iteration. We also need to do this initially. Otherwise it'll just be 0. We're not going to do the normal reset mapping squares. We're going to say for square in self.mapping squares. So what we're going to do, let me just break this down. We reset mapping squares to the endpoint and copy to local copy. While our local copy is not empty, we reset the local copy. For each square in the storage, we are going to clear out the list. Really, all we have to do here actually is just say self.mapping squares is a blank list. But what we're gonna do instead is say for the square in the mapping squares, we're going to set it to brown. We're going to collapse it. We're going to make it a wall. I think that's it. And then we're just going to reset the mapping squares. And then from our current iteration, we're going to find the next squares. And then the next squares finds the valid squares. The problem is it's going to check if they're mapped. So all we need to do is actually check we're just going to copy this logic. So we're going to say x, y is square index to position. We're going to define our function here. We're just going to call it unmapping check. Why not? And we're going to determine if it's mapped, if it's in the bounds, and if Yeah, we should just be able to check if it's mapped, because we're not going to map something that's not a path, so we don't have to check if it's a path. We're going to append it to the mapping squares. And we're not going to check map to square. Actually, that was a good name for this, because it would have been a mapped square. We're just going to do unmapping check. But we don't want to just do this. We want to do x plus 1. We want to do all of them again. Oh, this is x minus 1. So y, so we're going to do 1 to the left, top left, top right, right, bottom right, bottom center, and bottom left. That should be it. Let's see if we end up with weird bugs this time. We shouldn't. We shouldn't even hit that point. Well beyond our threshold. So as long as we take like more than 100 steps. See, if we end up in a position where we're in one of these really small caverns, we won't be able to take more than like 5 steps. So we won't end up in that position. So yeah, I think this is a good breaking point for now. I've got to get some actual work done. When we come back, we will interpolate the colors to give us more of a color coding, and we will add the path tracing back to the start. Both of those should be pretty easy, and then we can implement the factor for creating more start locations. And I keep forgetting to share this on the correct screen. So now we have this almost somewhat playable map. And just to make sure we don't have any problems, I want to go back to our UI and re-enable the UI. And look at generating points. If self, it's not a function. It's if not walking. Oh, we are spawning. It's just hard to see the green on the something that would be nice to add is resize for the windows. So yeah, it's going to be pretty cool seeing these paths come into play. But we will do our map coloring, and then our pathfinding, and then we'll basically be done. That'll basically be it. Yeah, it's gonna be interesting seeing these. So these would end up lying on the same path. For example, most of these would probably converge at a certain point around here, so it's gonna be super interesting to see. Yeah, anyway, that's about all we have time for right now. I'm gonna have to take a break, and we'll get back to this in the next episode, wrap it up. Thanks for watching. If you guys have any questions, let me know.